All right. World War II has happened. The Allies defeated the Axis powers. The guns are silent. The last bombs have fallen. Peace has returned to the world. Um, Obviously, it was a short lived peace, but it was to a point where we were able to finally pick up with where Guy Stewart Calendar left off. So now going into the mid 20th century, once again, climate science wasn't the most important thing on most people's minds. Europe had been devastated. Japan was now occupied by the United States. There was a communist revolution happening in China. The Soviet Union was starting to strengthen its grip on Eastern Europe. The world was very rapidly changing and evolving, and there was also a lot of reconstruction happening. However, global warming did not take a break during this time. And that is where we're picking up now. So here's what happened after World War II. This is taken from our textbook. In the late 1940s and 1950s, so after World War II has ended, several scientists began to see other disturbing signs of warming. Hans Ullmann suggested, based on his observations of Northern Europe glaciers, that those glaciers were starting to shrink in size, that they were going into retreat. Helmut Landsberg, originally a denier of climate change, somebody who originally thought this isn't happening, we don't need to worry about this, began also seeing evidence of significant warming in the 1950s. So the stage was starting to get set. More and more scientists were starting to come out and starting to be very worried about what was happening. So Ullmann and Landsberg started seeing evidence of increasing global temperatures. Now, that being said, okay, that supports Calendar's suggestions that the Earth was warming up. But what also is important is we need to know why. Guy Stewart Calendar had suggested that carbon dioxide, which once again, the relationship between carbon dioxide and temperature was first discovered by Eunice Foote. We needed to build on their conclusions to see, is carbon dioxide going up as well? Is this being caused by carbon dioxide? Well, in the late 1950s, enter a gentleman named David Keeling. David Keeling from the Scripps Institute of Oceanography, hosted at UC San Diego, began tracking and measuring carbon dioxide concentrations. His observatory that he began tracking them at was located on Mauna Loa, on the big island of Hawaii, out in the middle of the Pacific Ocean. The reason why doing it in a place like that is very important is because you basically drown out all of the noise caused by humans. And I don't mean like physical sound noise. I mean noise as in the day-to-day changes in human activities. Bonfires, electricity generation, cars, all these things that we as humans do that can impact carbon dioxide concentrations. We drown all of that out, and we're just looking at the upper portion of our atmosphere where carbon dioxide is well mixed. So we get a nice baseline of carbon dioxide and how it's changing. He began monitoring carbon dioxide at Mauna Loa Observatory in 1958. In 1958, carbon dioxide concentrations were approximately 315 parts per million. In 2018, 60 years later, carbon dioxide concentrations were approximately 410 parts per million. Now, these are not the exact numbers that you're going to do in your first module activity, but just to help you with the calculation, here is how to do it. So if you want to know how much carbon dioxide concentrations, how much parts per million have changed since 1958, What you would do is you would take the 410 number, the number from 2018, you would subtract the 1958 number. This would give you what you call the rise. So if you remember from algebra where you're calculating rise over run to figure out slope, this would give you your rise, the change in carbon dioxide concentrations over these past 60 years. This would give you a number of about 95 parts per million. Meanwhile, the difference in time, the run in this case, was 60 years. So 2018 minus 1958, that's 60 years. So to calculate how much, on average, carbon dioxide concentrations are changing per year, you take the difference from 2018 and 1958, and you divide it by the difference in years, which would be 60, to give you, this is going to be a number somewhere in the 1.5 parts per million per year. So that is how you do it. When you look at this week's module activity, you're going to see more precise numbers. So you're not going to get this exact number, but this is how you do it. So I do want you to know how to do that because you are going to have to do it on this week's module activity. You're going to have to do that in addition to a couple of other things. None of them should be that particularly difficult, but you are going to have to do that. All right. So let's take a quick look at the Keeling Curve. So here is the Mauna Loa Observatory. This is on top of Mauna Loa. This is actually upwind of the volcano because Mauna Loa is a volcano. So the prevailing winds are blowing away from the observatory towards the volcano. So the observatory is not getting any influence from the volcano. David Keeling considered that when he put up this observatory. And this observatory has been measuring carbon dioxide concentrations for the last roughly 62, 63, 64 years. And once again, at 11,000 feet in the middle of the ocean, that isolates it from all human activity so that we can just focus on carbon dioxide itself and not have to worry about cars driving by and changing the numbers. Here is the ultimate result with what he has come up with. This is the world famous Keeling Curve. And it's called a curve because it looks just like a curve. If you notice, global carbon dioxide concentrations have just kept going up, 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 and up. They just keep going up. We have gone from the mid 310s in the 1950s to now around 410 and even a little bit higher than 410, depending on the time of year, in 2019. So we have seen a substantial increase in carbon dioxide. Now, some of you may be taking a look at this and going, but it doesn't just go straight up. Kind of zigzags, right? I like to call that Bart Simpson's hair. It's kind of like Bart Simpson's hair. It goes up, then down, then up again, then down again, then up again, then down again. The reason why that happens is because carbon dioxide does undergo a seasonal cycle. Every springtime, trees wake up, they begin to grow new leaves. Those leaves perform photosynthesis. Photosynthesis gobbles up carbon dioxide. During that time, concentrations go down a little bit. Then fall comes, trees go to sleep, they begin to shed their leaves turn into this beautiful yellow, then orangish, then reddish color. You get your pumpkin spice latte, you put on your brown boots, you go out, You take pictures, post them on Instagram, loving fall. Well, those trees are going to sleep. And because they're going to sleep, they stop performing photosynthesis. As a result, carbon dioxide concentrations go back up. Then the next spring, they go back down a little bit, and then they go back up again. It's very important to not look at just a single month-to-month change, but to actually look at the overall trend. Otherwise, you could hear somebody, a pseudoscientist who believes that because it's cold outside, global warming is fake, and they'll say, well, don't you know, carbon dioxide concentrations have been going down the last 3 months. Seasonal cycle, that's why. If you look at the big picture, though, the overall trend, it's not looking good. It's just going up, 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 and up. And this is a very concerning pattern. This is a very concerning pattern. Now, that being said, as we started to get into the later part of the 20th century, we now have evidence. The world is warming up, and carbon dioxide concentrations are going up as well. Can we predict what will happen next and what implications it could have on humanity? Talk about that next time.